right. So all right. So what about this?
Okay, so this would be, I'm thinking the multiples of 8. 8,
Okay.
16, or no, I'm sorry. We're talking about addition,
Yes.
so yeah. Yeah, the multiples of 8, I'm
Yes.
sorry.
Yes.
So
Yes. That's
8,
right.
16, 24,
Yeah.
etc. I stopped there because we surpassed the other set.
Well, wait a minute. This is a
And I
subgroup of this, right?
well, yes, and I think that's where I'm very confused by the whole factoring thing. So if this is a subset of Z24,
Yes.
then the 24 would have to be a 0.
That's right. It's a subset. It's a subgroup. So you're using addition mod 24.
Mm-hmm.
So that's right. That's right. That's exactly right.
Yes.
When you say Z24 mod angle brackets 8, you're assuming that angle brackets 8 is a subgroup of Z24.
Okay, and I was very, I mean, I think that forward slash is a little confusing and might warrant a little bit of explanation.
All right, so let's go back and see what it says about forward slash. Where are we? Here. All right, forward slash is defined all right, let's see. If n is a normal subgroup of group N, G, then the group of cosets under the operation of set composition is denoted as G/N. So there's your forward slash right there.
Mm-hmm.
So the G/N is a set of cosets of N. For example, in this case here, if you take Z mod NZ, the way we say this is we say G mod N.
Okay.
That's the way you say it. So here we have a Z mod NZ.
Okay.
So these are all the cosets of NZ in Z. Actually, we did Z mod 3Z, so let's go there. These are all the cosets of 3Z in Z.
Yes, and that's why I was able to get through the example A because it was Z mod 4Z, which I was able to replicate, and I understood that.
Right.
And then I got confused.
All right, well, this is a set of cosets. Notice that it's Z mod 3Z. So it's a set of cosets of 3Z in Z.
So the integers, I can see clearly they're broken apart into 3 different cosets.
Yeah.
That totally makes sense to me because once you start 3 plus 3Z, you're back to 0. So that totally makes sense to me.
Okay.
But for some reason, when I got into the next example, I was not sure what to do.
All right, well, let's see if we can try to draw some connections between this example and others. Here we said that Z mod 3Z was a set of cosets of 3Z.
Yes.
So that means that if you have this slash thing, let's call this, it's not really, but let's call this the denominator.
Mm-hmm.
Then this is a subgroup, right? This has to be a subgroup of the numerator.
Okay.
Denominator is a subgroup of the numerator.
Okay.
So this fraction here is a set of cosets of the denominator.
Okay.
The fraction is a set of cosets of the denominator.
Okay.
All right. So it's going to be a set of cosets, and the cosets are cosets of this denominator. So let's go here.
Mm-hmm.
And so now we want Z24 mod 8.
Mm-hmm.
So this is going to be, it's a set of cosets of what?
Of Z24.
Well, let me go back here. I said that Z mod 3Z is a set of cosets of 3Z. Where 3Z is the denominator.
Right. But
All right, so let's go back
okay,
here.
okay. I get it.
So what do I put here?
I mean, I guess you put the angle brackets 8.
Yeah, that's right. That's the pattern. That's the pattern.
Mm.
All right. So, well, I can also be more specific. The set of cosets of 8 in what group?
In Z4. I mean Z24.
In Z24. Okay, good. All right, so what are the cosets of 8 in Z24? Now, there's always an easy one.
Well, we'll have 0.
Is that a coset?
No, 0 times angle bracket 8.
All right, now what's the group operation?
Oh, I'm sorry, plus.
Okay. Okay, and this is equal to?
Angle bracket 8.
Well, it's equal to 816.
816, 0.
Well, let's put the 0 first.
Yes. I saw a place that put the 0 and the 8 and the 16 in square brackets.
Well, yes. In fact, well, you would put all of these in square brackets. I'm being sloppy here.
What does that mean?
Well, because the point of this section is that modular arithmetic itself can be thought of as arithmetic of cosets. And cosets are equivalence classes.
So square bracket 8 means 8 mod 24?
Square bracket 8 means the set. So, I mean, if you want to do it that way, so you can say, let's see, we can say conceptually, Z24 is actually equal to Z mod 24Z.
Okay.
That's the new way of looking at it.
Okay.
Just like Z3 is Z mod 3Z.
Okay.
Now, what is this? This is the set of cosets of 24Z.
Mm-hmm.
So this is equal to 0 plus 24Z, 1 plus 24Z,
Okay.
dot, dot, dot. How many are there? What's the last one?
Would it be 20? I don't know.
23.
It's 23. Because when you get to 24, you get back to 0.
Okay.
Right? 24 is in 0 plus 24Z. All right, now this is equal to equivalence classes. The equivalence class of 0, that's the whole point of doing the equivalence class chapter. 1, 2, 23.
Okay.
So what we were doing before was we were using the symbol 0, 1, 2, 3, etc., and defining a new operation on them. That's what we did in chapter 2. We used the circle plus operation.
Mm-hmm.
But now we're saying, instead of defining some new operation out of nowhere, we're going to use the operation of set addition. So Z24 can be identified as the set of cosets of Z24Z in Z with the operation of set addition. Now, what's set addition? That's defined in the chapter here somewhere. Here it is. It's right here. Okay. So the upshot is that we're looking at something we saw before in a new way. Now, if we want to use this new language, we would say, so using this new language, the only difference between this new language and the old language is you just put square brackets around everything. Using this new language, Z24 would be equal to equivalence class of 0, equivalence class of 1, all the way up to equivalence class of 23. Angle brackets 8 would be the equivalence class of 0, equivalence class of 8, and the equivalence class of 16. All right, so what about the cosets of angle brackets 8? One of them is 8 itself, which we can write as 0 plus 8. All right, what's another coset?
Would it be 1 plus 8?
Okay, all right, so what is that set? So this is equal to 0, 8, 16. What about this one? What is this set?
1, 9, 17.
It is, yes. And if you work it out with set addition, in fact, that's true. If I take this coset of Z24, this is all the multiples of 24. This is all the multiples of 24 plus 1.
Yes.
If I take any multiple of 24 and add it to a multiple of 24 plus 1, I get a multiple of 24 plus 1.
Mm-hmm.
All right, so this is going to be 1, 9, 17. Okay. And go on from there. How many cosets are there?
There's a formula for that.
Yes. Altogether,
8.
there are, how'd you get 8?
24 divided by 3.
24 divided by 3 equals 8 cosets by Lagrange's theorem.
Okay. Very helpful.
Okay.
Okay.
So those are additive cosets. Now don't get messed up with the multiplicative cosets. It's the very same procedure. As long as you understand the what's going on. So here I put angle brackets 8. I mean I could possibly put angle brackets square brackets 8. I could do that. But I think it's see here I didn't. Well, or I did somewhere though. Well, actually, we didn't use the angle brackets notation until after this, I think.
Mm-hmm.
I don't think we used the angle brackets notation until after this. Wasn't it the next set? Or maybe it was before.
We have used it before, but it was probably only once because I had a very difficult time. I I thought I knew what it was and what I thought was correct, but we haven't used it a lot.
Well, it must be the only place. Let's see. Oh, that was in the equivalence classes chapter.
I think it, yeah, well, I don't know. I was looking for it everywhere because it's a permutation, basically. Yes?
No, it's not a
Or
permutation.
cycle, or I don't know.
No, it's a subset. It's an evenly spaced subset. Well, here it is.
I looked for it everywhere.
It's right here.
Square bracket?
Yeah, right here.
Oh, I thought we were talking about angle brackets.
Oh, angle bracket. Angle bracket is angle bracket was the orbits. That was in cyclic groups.
Yes.
So that's
Okay.
cyclic groups is here. It's right here.
Yes. I could not find that for anything.
Okay.
And I thought I knew what it was, but, and I was right. So
Yes,
thankfully,
okay.
but
Okay. I can put a comment in the next edition.
let's see, what else? I think that's going to go a long way to help me finish up,
Okay.
really. So I'll just leave it to anyone else.
When is this due anyway? Is it due tomorrow or tonight?
Tomorrow.
Okay.
Tomorrow.
All right. Well, I think I better leave it as tomorrow so you have time to work on the exam. So I'm going to release the exam after tomorrow.
Okay.
And you can have, well, you can have until Sunday midnight.
All right. That works.
Actually, you can have until Monday morning, but I think most teachers won't be able to do that. Unless when does your school end? Your school runs till the end of the month, right?
Yeah. School ends May 30th.
May 30th. Okay.
16 more school days left.
Okay. Yeah. Okay. Well, let's see. Because in any review for the earlier chapters, I want to give before releasing the exam, because then it's too then I would get questions that are too pointed. So how do you want to do this? Do you want me to because I don't know, maybe on Wednesday you'll be finishing up the homework, this homework. You want me to have a review on Thursday instead of Wednesday?
I would love to have an opportunity to ask questions about previous assignment before I start my exam.
Well, my question is, if I do the review on Thursday, is that going to give you, will you have enough time on the weekend to work on it?
Yeah, for me personally, yes. I don't know about everyone
Or
else.
how about you other people?
Yeah, I just can't do tomorrow because I've got the graduation orientation.
Okay. When does that finish?
I don't know. I have to be there at 5:30.
Oh, that's not going to be long. That's not going to be long at all.
I'm hoping not.
No, it's very, I certainly less than an hour.
Yeah, I'm hoping not. That way I can get this homework done too.
All right. Well, so then how should we do this? I get the feeling that people are going to be working on this homework tomorrow. Is that accurate?
Well, I'm gonna work on it tonight and tomorrow.
Okay. Well, I mean, so it seems to me the two options are either I review previous chapters tomorrow night or Thursday night, and I think I think so far what I'm getting is Thursday night is better.
Yeah,
That works-
Thursday night's
yeah.
best for me.
Personally for me, but I don't know about what everyone else is. But my weekends are my big time to
Yes,
do.
yes, okay,
Or
yes, I understand. Sure. Now I could have another session on cosets tomorrow night.
So then that would push a review even further,
No,
or
no. I mean, then people who want to finish up cosets, we can talk about cosets.
Okay.
Amanda, you could just stop by after the orientation.
Yeah.
Uh,
Will you have the meeting on campus, or would it be online?
as it turns out, I'm on campus now.
Okay.
So yes, it would be on campus.
All right. But that'll work too, since I'll already be there.
Okay. So should we just say 6:30 tomorrow? Finish up cosets, and I should
Yeah.
stop the recording here. People don't need to hear this.